So we'll be talking about this evaluation as per CBSE curriculum. In class 10th, CBSE is talking about evaluation of a model, which is a classification model. So what generally happens is when the model after data exploration, when the data is cleaned and readied for the AI algorithm, then the model is trained with the data. After training, when the model is tested to be deployed in the real life scenario, then it is assessed whether it is reliable or not on certain benchmarks. Now, a model which has to be reliable, first of all, has to be accurate. Whatever it is predicting, a classification model will be predicting this thing will happen or this is it or not. Like, for example, identifying the tumor cells in medical field, or recognizing a face, or predicting some sort of weather condition, or predicting whether the flood would happen or not, predicting whether the customer would return this product or not. So these kind of predictions in yes, no kind of, if these predictions have to be kept into a particular class A, class B, yes, no, true, false, this will happen, this won't happen, then this is a classification model. And for that, we look at how such model is evaluated, on what fundamentals this model is evaluated. The very first one is your accuracy. Accuracy is simply how many, suppose a model is doing some predictions. Out of the predictions done, when we compare it with reality, how many comparisons have been done correctly? That is the accuracy. It can be calculated in simple percentage terms. Out of all the predictions done, how many predictions were correct? That is the accuracy. Now, as far as model is predicting something positive, like this thing will happen, or if the model is predicting something which is not very life-threatening, then accuracy can be taken into consideration. But suppose a model is going to predict that these are not cancer cells, and if that model's accuracy is 98%, in 2% cases, the model predicted wrong. The model said that it is not a cancer cell and it was a cancer cell. So this is a life-threatening situation where we have to have the model 100% accurate, and we cannot leave room for any wrong predictions. So in such cases, we cannot go for only for accuracy. Accuracy, for example, suppose a model has to predict that a particular email message is a spam, is not a spam. Now that's not very life-threatening. Maybe it is marking 1 or 2 mails as a spam, which were important. They can be retrieved from a spam box and can be read. So it's not, compared to a life-threatening situation, it is not much loss. So there we can go for accuracy. We can go for a trade-off. But in life-threatening situations, in sensitive situations, we cannot rely upon accuracy of the model unless it is 100% accurate. Also, if a model is giving 100% accuracy, still questions remain, because model will be tested with real life data. The model has been trained with a different kind of data. Suppose the model which is trained with the data, that data which is used for training, if that data is not a very balanced data, and it is not very rich with all the possible combinations, then the accuracy of the model, no matter if it is 100%, it cannot be reliable. So accuracy alone, no one will be satisfied that a model which is giving 100% accuracy is also reliable. Now, when a model is giving 100% accuracy, that means whatever questions are asked by the model, all the questions were correct. All the answers to those questions were correct. That is 100% accuracy. Now, a model which is trying to answer all the questions correctly, this situation can also be considered as overfitting. The model is not trained well with a rich kind of data, with a diverse kind of data, and it is trying to match all the real conditions with true predictions, and that's why accuracy is going to 100%. So alone, accuracy cannot be a benchmark for a model to be made eligible for deployment. So what all other metrics are there that we will look into? If we take a situation like Miss Sudha, maths teacher, is there, and she's very strict, and children are very scared of her. She is very disciplinarian and authoritative in the classroom, and like a maths teacher, the children try to be just in discipline in classroom. She's very strict. So one day it was heavily raining and children were praying that she should not come today. So we'll have a free period. So children predicted that, okay, Sudha ma'am, maths teacher, will not come today. And actually she came. She had been a very regular teacher and she really came with a big umbrella. She entered the school and children had to study again. There was no free period, unfortunately, for them. So children predicted something will not happen and it happened. That is one aspect. Another scenario is other way around. There is a student who is not very regular. His absenteeism is highest in the class. And the class teacher said, while taking attendance, this student will be absent today. So teacher is saying, this student will be absent today, and to everybody's surprise, that day that student came. Again, the prediction went wrong. So there are two aspects. Prediction by the model will be done for something to be happening or something not to be happening. For example, prediction would be the flood would come. There would be a forest fire. There would be a bad air quality index next year. So these are some predictions which are saying that, yes, this will happen. And if it happens really, then that prediction is true. Otherwise, that prediction is false. It is incorrect. The other aspect is we say that something will not happen. The model predicts that this will not happen. This message is not a spam. This cancer cell is not, it's a healthy cell, it is not a cancer cell. So the other aspect is the model is predicting that something will not happen. And it might happen, it might not happen in reality. So depending on that, the prediction might be true or false. So these are the two aspects of predictions, predicting something to be happening and predicting something not to be happening. So with these permutations, when we try to evaluate the model, then we check for two things of the model. Number one, how precise the model's performance is, how precisely the model is performing, the prediction of the model is how precise. And the second aspect is how much is the recall of the model, how much the model can recall. Now, these two terms to understand, let's take a small example. Let's say there are 26 alphabets in English, A to Z, 26. So if I speak to you, when I'm talking about these alphabets, I say alpha, B, C, D, E, alpha, B, C, D, E. So out of those 26, I could iterate 5 of them. One of them was incorrect. It is not alpha, it is A actually. So out of these 5 which I have taken out, which I have spoken, the first one was incorrect and the other 4 were correct. So whatever I have predicted, whatever I have taken out, it is 5. Out of 5, my 4 predictions are correct. B, C, D, E are correct. They match with the alphabet letters. So out of these 5, 4 are correct. My precision, I repeat, is good. It is 80% because I'm looking for the precision in what I have given as output. I'm not going to those 26 letters. So my precision is good. But what about the recall? My recall is very bad. Out of 26, I could recall 4, that too 1 was wrong. So out of 26, actually, my recall is only 4. I could not recall rest of the alphabet. So that's the difference between recall and precision. Precision will always consider what has been predicted, and recall will consider the entire reality. So we will go into another example practically, and we'll see how this precision and recall are different from each other. Then we will see in what situations precision is important, in what situations recall is important, or either we need both of them. We need a balance of them. We'll see that. So here we are trying to understand, first of all, what is recall and what is precision. So let us consider a situation where, look at this, no need to look at the entire sheet and try to get, you'll only confuse with it. Look at this part which I'm highlighting. This is the scenario where we have a photograph of 10 bicycles and 12 bikes. A model is given a photograph to identify 12 bikes, and there are 10 bicycles also in the photograph. So which one is the relevant element? Relevant element is bike, because model is asked to identify the bikes in the photograph. And in that photograph, there are 10 bicycles also. So this is the situation. Now, what model actually is doing is this. This is the performance of the model, which I'm highlighting now in the testing part. We asked the model to identify the bikes. What model did is, model identified 8 items, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. These 8 items. So model actually identified 8 items and said that these 8 items are bikes. Now, out of those 8 items which model identified as bikes, actually 2 are bicycle. So model incorrectly identified 2 bikes. 2 bicycles it mistook for bike, and 6 were correct. So out of 8 output, model was correct in these 6. You see here, 1 means correct. And model identified 2 bicycles also, saying them that is bike. So even if I'm saying yes, this is 0 here. So this is the situation with the reality. So model predicted this, and this is the reality, that 2 are bicycles actually. Now, how do we consider? Now, actually 6 bikes are identified. So model said, 6 times model said, this is a bike and this was a bike. This is a bike, this was a bike. This is a bike, yes, it is a bike. So 6 times in 6 cases, the prediction is correct. So prediction was in positive. It is a bike. That's a positive statement. So there are 6 true predictions, 6 true positive predictions. So here it is, actually 6 bikes, we will call them true positive. So what is true positive? Now this is a new term which has come in here. True positive means when a prediction is done for something to be happening, something to be, that is positive. And if that prediction is correct, it is called true prediction or true positive. If that prediction is wrong, like in case of these 2 bicycles, you see these 2 bicycles, the prediction was done for something to be. This is a bike, but actually it was not. It was false. It was not a bike. So whenever a positive prediction goes incorrect, it is called false positive. So there are 2 false positives. There are 6 true positive out of what model has performed. This is the output of the model. 2 false positives, 6 true positives. So true positive and false positive is understood. Now, model was looking at the entire photograph. In entire photograph, there were 22 objects. So we can say that the model could not identify 8 bicycles. Actually, model could not identify 8 bicycles, but model was looking for bike. So they can be considered as true negatives. Model saying it is, when model was looking at all the objects, model would have said, this is not a bike. And yes, it is not a bike, it is a bicycle. This is not a bike, it is a bicycle. This is not a bike, it is a bicycle. This happened how many times? 8 times. So 8 true negatives are there. Now, true negatives means model said, model predicted something not to be. Model predicted that this is not a bike. And yes, it was not a bike. It was, the prediction was in negative, but the prediction was correct. That happened 8 times. So a negative prediction got correct 8 times, hence 8 true negatives. You got this? True negatives means something which has been predicted being not to be, in actually also it does not happen. So this is true. And prediction was done for not to be, not means negative. So it is true negative. So for these 8 bicycles which were left out by the model not to be identified as bike, actually model was correct. So true negative. What is left out? Whatever is left out is false negative. Now model was looking at the whole photograph for these 6 bikes. These 6 bikes, actually model said, this is not a bike and it was actually a bike. Model was incorrect. Model is saying this is not a bike. Model is predicting something not to be, and it was actually a bike. Model was wrong in prediction. So there are false negative. There are 6 false negative. So always remember, false positive and false negative are called errors. They are errors. Whenever model goes wrong, false happens. If model says this will happen and it does not happen, false positive. If a model says this will not happen and it actually happens, that is false negative. So whenever you find out false positive and false negative, they are called errors. And if false positive and false negative is very much higher, then model needs more training. Simple fundamental. Whenever false positive and false negative are higher, model needs more training. So now we understand, we have understood true positive, true negative, false positive, false negative. Now we understand recall and precision. Now let us look at this part again. This is actually model predicted. Out of these predictions, 6 are correct. 6 identification of bikes are correct. So only out of this, if we consider, precision is considered only with the output what model has predicted. Rest we ignore. So out of this 6 are true positive, correct predictions. 2 are incorrect predictions. They are false positive. These 2 are considered to calculate the precision. Precision is calculated as true positives divided by the sum of all the true positives and false positive. That is 6 and 2 here. So it is 6 by 8, 0.75. Precision is very high. Precision is very high because out of these 8 cases, 6 are correct and only 2 are incorrect. So we are only looking at a particular part of the entire thing. So precision alone is not going to tell you that a model is eligible for deployment, because many things are ignored. What is ignored? 6 false negatives are ignored. 8 true negatives are ignored. And we are only looking at this part. If we look into the definition of precision, precision is only considering true positives and false positives, this part only. And by common sense, we can see precision is very high. It is 0.75. It's good. Precision is always between 0 and 1. And this is very near to 1. So if we consider only precision, we will deploy this model. And this model will only be able to identify half of the objects. It's not good. That is why we look at what is the recall of the model. Now, recall considers entire relevant elements. Relevant elements were bikes. Bikes had to be identified. There are 12 bikes. Out of these 12, not only the model failed to identify half of the bikes. This is called recall. How much a model can recall from the training? The model was able to recall only 50% of the objects, the bikes. That is why you see recall takes into consideration false negatives also. There were 6 false negatives. 1, 2, 3, 4, 5, 6. 6 times the model failed to identify the bikes. So here in recall, the consideration for the failure of the model is also being considered. And when we do that, we find that recall is only 50%. So precision is very good. Whatever model did, it was precise up to the mark. But when we look at the entire data set, we saw that recall is very less. Recall is 50%. And that's why this is an imbalanced situation. There is no balance between precision and recall, and model needs to be trained more for this prediction. So with this sheet you will get, and with this single sheet, you can make the students understand true positive, false positive, true negative, false negative, these 4 things, how to understand them. With this example, you can teach them the precision and recall, how do they look like, and what do we mean by the balance between the two? So if I say, I make some changes here. If I say that model was able to identify more bikes, see how nice. Now they are completely in balance, 0.8, 0.8. It's a very good model. It can be deployed. And if I say, if I increase this, now see what is happening. Model is identifying some more bicycles incorrectly. See how the figures have changed. False negative, true negative have gone higher. The error has gone higher. If I reduce more bikes to be identified here. So now see the situation. This is the performance of the model now. Model was able to recall only 3 bikes, and it had identified 1, 2, 3, 4, 5, 6 wrong predictions it has done. Look at the condition of the precision and recall. They are in a very pathetic condition now, very poor. Poor precision, poor recall. Did you see? So just by changing the values here, you can make the students identify what is the meaning of recall and what is the meaning of precision. Oh, wow. It's an ideal situation here. Model was supposed to identify 12 bikes. It has identified all the 12 bikes. Precision is perfect. Recall is perfect. So what I actually was telling you, this is another example. Now you will be able to understand all this. So a model is doing some positive prediction and the model is doing some negative prediction. And see how the error is shown in red color. Always remember, false is always error. True is always the model was correct. So here it is. Whenever the model is predicting the cell is a tumor, and if it is a tumor, it is good. It is actually correct. Tumor is not good, but yes, result was correct. But if it is saying the cell is not a tumor, that's false and model has failed there. And below you see this is the reverse situation. So if we combine them, what we get is called confusion or error matrix. So the prediction, if all the positive predictions, you have to see how many positive predictions were done and how many of them were really true. That is true positive. How many predictions were done for something not to be, and actually it happened, actually it was. So that is, it becomes false negative. Or if something is predicted that something is not to be and it really did not, then it is a true prediction, true negative prediction. So now you should be able to understand true positive, false negative, true negative. And the simplest way to understand is you just remember one line, that false is error. If you remember this line, false is error, rest of the things you can easily remember. Now we were looking at this example. So what did we learn out from this example? Let us summarize. When we talk about precision, it focuses on the output which the model has given. So when we are looking at precision, actually we are discussing how valid the results are. If you see, precision is pretty high, 0.75. So results which came out were valid. Out of 8, the 6 predictions were correct. It is looking good. So results are valid. What else with precision is there? Precision actually measures the quality. Out of the result, how good, how valid is the result? So precision is talking about quality. And more relevant results are returned. If precision is higher, that means more relevant results are returned. Here 6 relevant results are returned. So precision is pretty much higher. And when we say perfect precision is 1. When all the relevant predictions are correct, then that is perfect precision. Now, in contrast to precision, if we talk about recall actually focuses it whether the result returned by the model is complete or not. And if you look at the situation below, the result is not complete. 6 bikes were left out. So recall is actually looking at the negative side also. So it is actually measuring the quantity. It is asking the real numbers. Okay, Mr. Model, you have done 10 predictions correct, but what about the 20 others which are left out? What about the 20 errors? So it is talking about the quantity. And if it is 1, that means 100% recall is there. So this is the contrast between precision and recall. Precision is talking about only what the model has given out. Recall is also considering the failure of the model. And that is why this formula is there. Precision is considering only the false positive, but recall is actually considering false negative. So there has to be a balance between the two. If precision and recall are almost the same and they both have to be higher also. It's not that precision is 0.2 and precision is 0.2 and recall is also 0.2. They are balanced, but they are low. So they both have to be high. High means 7 or above. And they both have to be near to each other. So that balance is called F1 score. So always remember, whenever your precision and recall is high, your F1 score will also be high. If any of these are low, your F1 score will come down. See here, if I make the precision higher, see now precision is 0.8, it's almost 9, recall is pretty high, 0.67, let's say 7. So precision is 9, recall is 7, F1 score is 0.8. So this model seems to be good and it can be deployed in such a situation. So when precision and recall both are higher, F1 score will go high. It's the formula, 2 into precision into recall divided by precision added with recall. So with this formula, you can find out the balance between the, this is called the F1 score is called the harmonic balance between precision and recall. See, let me say this is the performance of the model now. Now see the situation of F1 score. Both precision and recall are low. Obviously, F1 score is low. If I make the precision higher a bit, so did you see? Precision has gone lower. No matter recall is high, but F1 score is low. It is 0.6. So it is 0.6 because here so many wrong predictions have been done. As many correct predictions were done, almost equally the wrong predictions were done. So this model cannot be deployed. So this way, the balance between the two, precision and recall, is done. Like another example is here for you. That is by the help of the confusion matrix. Here total 22 cases are there. True positives 6, false positive 2, true negative 6, false negative 8. And see the condition of precision, recall and F1 score. F1 score is low because recall is low. So if I make changes here, I can see the precision and recall. You can give this to the students in lab and they can practice themselves. You can give them a situation on the blackboard or on the projector and ask them to fill up the figures according to the given scenario. The students will fill up the figures here and they can easily figure out what is the precision, what is the recall, and what is the F1 score. So this way they will understand the concept. Now here, if I say 22 cases, this 22 cases should not change. There are 22 cases. Suppose I say it's a very low true positive. So this is 2. I have to keep the total 22. If this is 2, it was 6, then I make, if this is 3, I make it 5. So 22. So 3 predictions were correct. That means 5 predictions were not correct. So this way, they can make changes. If I take, say, 33, 15, 22, and 10. So this is the total 80. If I have to analyze out of 33, let's say there were more errors Instead of 15, it is 20. So here I make it 28. The total has to be 80. So 28 correct, 20. Now everything is low here because the errors have increased. If I increase the errors more, 25, so this is 23, still there, the precision and recall is going down. So this way, I can analyze out of this 80 cases, if I say there were 50 correct precisions done, 50 correct and only 3 incorrect, one, let's say 10 here and 7 here. I have, sorry, 17 here. I made it 80 again. But see, true positive is pretty high. And see, precision and recall both are high. F1 score is very good. So this way, by making changes, students, you can open a discussion in the lab. You can discuss with the students different scenarios. You create the scenarios, show them, let them fill the figures and make a discussion. So this way, the students will be able to understand from this example and this matrix, they will understand the concept easily. So thanks one and all.